Good morning to all of you. In previous session, we were discussing about properties of discrete Fourier transform, where we have seen periodicity and linearity property. Today, we'll be discussing another property, which is also called as multiplication of two DFTs, as well as it is referred as the circular convolution property. So, in today's session, we'll be looking at multiplication of two DFTs and circular convolution property, correct? So before this, we have already discussed the linear convolution. Okay, the convolution of x of n convolved with h of n is simply represented as y of n, right? The star operator is the convolution operator, and the formula for convolution is simply summation k is equals to minus infinity to infinity x of k into h of n minus k, where this second sequence is folded initially and then shifted by n samples. Okay, so this is nothing but the linear convolution. Okay, so this linear convolution we have already seen, correct? So it is a linear convolution. Okay, so in case of circular convolution in discrete Fourier transform, it corresponds to the multiplication of two DFTs, right? So as per this circular convolution property, if there are two discrete time signals with endpoint DFT, that is the discrete time signal x1 of n with endpoint DFT denoted as x1 of k, and the second discrete time signal x2 of n with endpoint DFT x2 of k, right? Then the multiplication of their DFTs in frequency domain, the multiplication of these DFTs in frequency domain will be simply indicated as x1 of k into x2 of k. So this multiplication of these two DFTs in frequency domain corresponds to the circular convolution of these discrete time signal in time domain. So this circular convolution is simply denoted as x1 of n. So it is convolved in circular manner with x2 of n. Okay, so this circle inside circle capital N is there, right? So this operator is called as circular convolution operator, right? As in case of the linear convolution, we have used this star operator. So this star operator is nothing but the linear convolution or convolution operator, right? While this what is indicated here is nothing but the circular convolution operator, right? So basically this is nothing but the multiplication of two DFTs, or which is also referred as the circular convolution property, right? So as per the circular convolution of the two sequences, if we are interested in identifying the circular convolution of these two sequences, just for example, here I will write down this circular convolution property, right? That is x1 of n circularly convolved with x2 of n is nothing but the multiplication of their endpoint DFTs, that is x1 of k and x2 of k in in the frequency domain, right? So this circular convolution is simply indicated as this, just for example, if I'm indicating as x of n, okay, the result of the circular convolution operation, if I'm indicating as x of 1 or maybe x3 of m, I will indicate it as, right? So if I'm indicating as x3 of m, which is nothing but the circular convolution of x1 of n and x2 of n, so as per formula it is simply denoted as summation n is equals to 0 to n minus 1, right? So basically, we have seen in the linear convolution these limits are from minus infinity to infinity. Here it is taken for capital N points, okay? So because the sequence will repeat itself after capital N period, right? So here the circular convolution is nothing but the x1 of n multiplied by x2 of in double bracket m minus n. So what does it means? So basically this x2 of n signal is folded in circular manner initially, okay? So it is circular folding and then it is shifted circularly by m samples, right? So this folding and shifting operations are carried out in circular manner in the circular convolution by taking by considering this capital N period, right? So that is the difference between the linear convolution and circular convolution. If I'm talking about the linear convolution, so x of n, which is nothing but the y of n, which is nothing but the convolution of x of n and h of n, okay, what we have seen. If I'm writing the formula for that, so it is n is equals to minus infinity to infinity x of n into h of, sorry, it will be x of, k is equals to minus infinity to infinity x of k into h of n minus k. Okay, so similar sort of operations are there, that is folding is there, right, and then shifting is there, then there is multiplication, and then there is sum operation, right? So same operations are here in case of circular convolution. This is nothing but circular convolution operation, okay, where the folding and shifting operations are carried out in circular manner, okay? So as per this multiplication of two DFTs or circular convolution property, multiplication of the DFTs, right, this multiplication of the DFTs of two sequences, we have taken sequences as x1 of n and x2 of n, so their respective DFTs are indicated as x1 of k and x2 of k. So this their respect so their respective discrete Fourier transforms multiplication, that is multiplication of the two DFTs of the sequences x1 of n and x2 of n, is equivalent to their circular convolution in the time domain, okay? So that is nothing but the multiplication of two DFTs or circular convolution property. So if I want to compare these two operation, that is circular convolution and linear convolution, that is circular convolution and linear convolution. So both these operations comprises these four operations, that is first one is the folding, okay, folding of any one of the two sequences, right? So here x2 of n has been initially folded to get x2 of minus n, okay? Second operation that will be performed is nothing but the shifting operation. So this signal which we have folded will get shifted by samples, okay? Then third one is the multiplication operation. So multiplication of the two sequences to obtain the product sequence. right? And then final operation is the summation or addition. Okay, so addition of the product sequence, whatever product sequence that we'll get. So same, these four operations are involved in circular convolution as well as linear convolution. The difference between these two types of convolution, that is circular convolution and linear convolution, is that in circular convolution the folding and shifting, okay, these folding and shifting operations are performed in circular fashion by computing the index of one of the sequences modulo n. Okay, so this capital N parameter plays a role of performing these circular folding and shifting operation. Okay, the remaining things are similar if you compare the circular convolution with the linear convolution. In case of this linear convolution, these folding and shifting operations are not performed circularly, right? So here we'll uh, discuss one example. In this example, we will be identifying the circular convolution directly by using the circular convolution formula, right? Without applying this circular convolution property or multiplication of two DFTs properties. Okay, so without applying those property or without using the DFT, the discrete Fourier transform, we will directly identify the circular convolution here, right? And in next session we'll be discussing the same problem, but there we'll be applying discrete Fourier transform or the circular convolution property to get the circular convolution result, right? So in this example that we'll be discussing in this session, we'll be directly identifying the circular convolution without using discrete Fourier transform. Okay, so here two sequences are given, that is x1 of n and x2 of n. So x1 of n and x2 of n, in both sequences the first sample is the origin sample. So to perform this circular convolution, so basically we are interested in identifying the resulting sequence as x3 of m. Okay, and the formula for the circular convolution is simply n is equals to 0 to n minus 1, right? Where this 0 to n minus 1 will be there, and the circular convolution of these two sequences will be performed, which is nothing but x1 of n multiplied by x2 of capital, basically it is m minus small n and a suffix capital N. Okay, so this is nothing but the circular convolution of x1 of n, which is circularly convolved with x2 of n, right? So as per the given sequences, if I'm just simply comparing these values here, right? So both sequences comprises 4 samples, right? So the value of capital N will be taken as 4, right? And the summation limits in this case will be from small n is equals to 0 to 3 in that case, because it will be 4 minus 1. So it will be x1 of n into x2 of m minus n, and suffix 4 will be there, right? So that will be the circular convolution. So basically here we'll be performing this circular convolution graphically. So it is desirable to graph each sequence as points on the circle to find circular convolution. So these sequences x1 of n and x2 of n can be graphed in counterclockwise direction on a circle. Okay, counterclockwise means anti-clockwise direction. So how these will be plotted on the circle, right? You can write down whatever statements that I have said, right? The sequences are graphed in the counterclockwise direction on the circle. So here you can simply draw one circle indicating the sequences x1 of n, and second circle where the second sequence x2 of n will be indicated, and you will plot it counterclockwise. So first sample, that is x1 of 0, in this case is 2, then next one is will be indicated x1 of 1, which is nothing but 1 here, the value is 1. Then next value is x1 of 2, so value is 2, and then x1 of 3, here value is 1. Right. Similarly, this x2 of n will be plotted counterclockwise, so it will be x2 of 0 is equals to 1, x2 of 1 is 2, x2 of 2 is 3, and x2 of 3 is 4. Okay, so these signals are plotted in counterclockwise directions, right, on the circle. So now this x3 of m is obtained by circularly convolving these two sequences, that is x1 of n and x2 of n. Okay, so we'll begin with m is equals to 0, right? We'll begin with m is equals to 0. So if I am substituting m is equals to 0 value in this circular convolution formula, so I will have this x3 of 0. Okay, so this n is equals to 0 to 3 will be there, 0 to 3 in x1 of n multiplied by, so m is equals to 0, so it will be x2 of minus n will be there, and 4 will be there, right? So this will be for m is equals to 0, right? So now see, we have already graphed this sequence x1 of n on the circle. So we have x1 of n already indicated here on the circle, right? But we need here x2 of minus n. So this, to get this x2 of minus n, so we have to circularly fold this x2 of n sequence, right? So how this will be circularly fold? So basically this x2 of minus n in suffix 4 is simply the sequence x2 of n folded and graphed on a circle, right? So this is nothing but simply x2 of n is simply folded circularly, right? As we are graphing, or that sequence is graphed on the circle, that means we are performing folding operation in circular manner, right? So simply again you will draw one circle, okay, where you will indicate this sequence, that is x2 of minus n in suffix 4, right? So to get this sequence, the folded sequence, circularly folded sequence, simply you have to graph this signal which we have graphed in counterclockwise direction. Now we'll graph it in clockwise direction, right, to get the folded sequence, right? That is nothing but x2 of minus n. So how it will be graphed? So this x2 of 0 will be at the same position, that is x2 of 0 will be here, right? So the value is 1, correct? This value will be here, right? That is x2 of 1 will be 2, because we are now plotting this sequence in clockwise direction, right? So here it will be x2 of 1, here it is x2 of 2, and here it will be x2 of 3, right? So how it will be plotted in clockwise fashion. So x2 of 1 is 2, x2 of 2 is 3, right? x2 of 1 is 2, x2 of 2 is 3, and x2 of 3 is 4. So it is here, the value will be 2, 3, and 4. Okay, so this is the folded sequence, okay, circularly folded sequence x2 of n, right? Now we have to identify the product, okay. As per this formula, we have to identify the product sequence, okay. So again we'll draw one circle here where we'll get the multiplication of x1 of n multiplied by x2 of minus n, then suffix 4. So depending on the position of sample, we'll multiply the respective samples here. So at this position sample value is 1, here it is 2, so 2 multiplied by, because we are multiplying x1 of n and this x2 of minus n, right? So this x1 of n will get multiplied by x2 of this minus n in suffix 4 signal, right? So here value is 1, here it is 2, so 2 multiplied by 1 will be 2, right? Here the sample value is 4, right? In this case it is 1, so it is, the multiplication will be 4, right? Here it is 3, right? Here it is 2, so 2 multiplied by 3 will be 6, right? Again here the value is 2, right? Here it is 1, so 2 multiplied by 1 will be 2, right? And to get this x3 of 0, okay, so here this particular graph indicates, circular graph indicates the folded sequence, okay, it is nothing but folded sequence, and this is nothing but the product sequence, okay. So to get the actual value of x3 of 0, we have to simply sum these values, okay, these 4 values for n is equals to 0 to 3 means these 4 values were to sum, okay. So the addition of these 4 values will be 6 plus 4 plus 2 plus 2 will be, it will be 14, okay. So we got the first sample, that is x3 of 0. Similarly we have to identify it for m is equals to 1 2 3, because the value of capital N we have taken as 4, right? And the value of m, this value of m will vary as 0 1 and so on up to n minus 1, okay. So this will be your capital M, sorry, small m, right? So it will be in our case it will be 0 1 2 and 3, because the value of n we have taken as 4, so it will be 4 minus 1, so total 3 values will be there, sorry, total 4 values will be there starting from 0 to 3. Next we will write down the formula for m is equals to 1, okay. So for m is equals to 1, again we have x3 of 1 is equals to summation n is equals to 0 to 3, this x1 of n will be as it is. So circular convolution, as per circular convolution formula we are substituting m is equals to 1 here, so it will be x2 in double bracket 1 minus n in suffix 4 will be there, right? So we already have this sequence, that is x2 of minus n, okay, which is nothing but the folded sequence, right? So we now want to circularly shift that sequence, okay, shift by one sample. So how it will be shifted? So to get this x2 of 1 minus n, okay, in suffix 4, basically it is simply the sequence which is nothing but the x2 of minus n rotated counterclockwise by 1 unit in time. So here again we'll be drawing one circle, right, where we'll be indicating x2 of 1 minus n, right? So on this circular graph we'll be plotting again this x2 of minus n, okay, but the sequence is simply rotated counterclockwise by one sample. So that means it will be rotated in anti-clockwise direction, so this x2 of 0 will be at this position, right? x2 of 3 will be at this position, x2 of 2 will be at this position, and x2 of 1 will be at this position, right? So this here it will be x2 of 0, here it will be x2 of 3, right? So we are simply rotating it by one sample in counterclockwise direction, right? So likewise the sample values will be specified here. So your x2 of 0 is 1, right? So it is 1, 4, 3 and 2 is there, right? So these values are simply rotated in anti-clockwise direction by one sample. So 1 came here, 4 goes here, 3 goes here and 2 goes here, right? So these values are plotted likewise. Now again we have to multiply these resulting values with x1 of n, right? So x1 of n multiplied by x2 of this 1 minus n will be there, right? So again the multiplication results will be indicated here. So 2 get multiplied with this 2, right, in x1 of n. So 2 multiplied by 2 will be 4 here in this case. So this 1 will get multiplied by 1. So 1 multiplied by 1 will be 1, right? Then this 4 will get multiplied by 2, right? So it will be 8, right? And here the value is 3 and here it is 1. So 3 multiplied by 1 will be 3, right? So again this is what is nothing but folded sequence rotated by 1 unit in time, right? And this is nothing but the product sequence. And by adding these values, okay, so we are taking summation, and by adding these values we'll get x3 of 1. Okay, so what will be the x3 of 1? So addition of these values. So 8 plus 1 plus 4 plus 3 will be 16. Okay, so similarly for m is equals to 2, for m is equals to 2, we'll have now formula in place of 1 we will be substituting value 2. So it will be x3 of 2 summation n is equals to 0 to 3 x1 of n multiplied by x2 of, here it will be 2 minus n. Okay, so it will be 2 minus n suffix 4. So again we'll be plotting it on circle. So it will be x2 of 2 minus n in suffix 4, right? So again to get this x2 of 2 minus n, we can rotate this x2 of minus n counterclockwise by 2 samples, right? Or this x2 of 1 minus n counterclockwise by 1 sample. That means this 1 will come here, this 4 will go here, 3 will go here and 2 will go here, right, in this x2 of 2 minus n, correct? So here this x2 of 1 will be at this position, right? So x2 of 1 will be at this position, correct? Next this x2 of 0 will be at this position, so here it will be x2 of 0, right? Next here it will be x2 of 3, right? So here it will be x2 of 3 and here it will be x2 of 2, right? So this x2 of 2 goes here, right? So we can write down these values here, whatever values the sample has. So x2 of 2 is 3, x2 of 2 is 3, x2 of 1 is 2, x2 of 1 is 2, right? x2 of 0 is 1, x2 of 0 is 1 and x2 of 3 is 4. So x2 of 3 is 4. So again we'll be multiplying this x2 of 2 minus n with x1 of n as per this formula. So x1 of n multiplied by x2 of 2 minus n, right? So again here the value is 3, so 3 multiplied by 2, so it will be 6, right? Here the value is 2, right? Here value is 1, 2 multiplied by 1 is, the value that we'll get here is 2, right? Here x2 of 0 is, I think x2 of 0 is 1, okay? I think I have written here 0, it is 1, x2 of 0 is 1. So this x2 of 0, that is 1, will get multiplied by value 2 here, so it will be 2 again, right? And this x2 of 3 is 4, right? So the 4 will get multiplied by 1, okay? So it will be 4. Again we'll add these values to get x3 of 2, so if you add these values, 6 plus 4 plus 2 plus 2, so it will be 14, okay? So this is x3 of 2, right? So last sample value that we have to determine for m is equals to 3, so again x3 of 3 is equals to summation n is equals to 0 to 3 x1 of n multiplied by x2 of 3 minus n, okay? So again to get this x2 of 3 minus n, again you will rotate these previously graphed sequence counterclockwise by one sample, that is x2 of 2 minus n will be rotated counterclockwise. So this x2 of 2 will be at this position, okay? So x2 of 2 will be here, right? Then x2 of 1 will be here, right? x2 of 1 here, it will be x2 of 0, right? x2 of 0 will be here, and in this case x2 of 3 will be here. So if I want to write down these values, so x2 of 2 is 3, right? x2 of 1 is 2, x2 of 0 is 1, and x2 of 3 is 4, right? Again I will be multiplying these values, that is x1 of n multiplied by x2 of 3 minus n, right? So here the sample value is 4. In case of x1 of n, value is 2, so 2 multiplied by 4 will be 8, right? So here the value is 3, so 3 multiplied by 1 will be 3. Then next, here the value is 2, 2 multiplied by 2 will be 4. Then value is 1 here, so 1 multiplied by 1 is there, so it is the value 1. So here I will get x3 of 30, right, by adding these values. So it will be 16 again, right? So x3 of 3 is 16, okay? So this is how you will perform the circular convolution, and finally you will write the circular convolution of x1 of n and x2 of n is simply x3 of m. So the value of x3 of 0 is 14, x3 of 1 is 16, x3 of 2 is 14, right? And x3 of 3 is 16, okay? So that means we have these values which will be written here, that is 14, 16, 14, 16, okay? This is nothing but x3 of 0, x3 of 1, x3 of 2, and x3 of 3. So this is how we can determine the circular convolution directly, okay, without using discrete Fourier transform or property of the discrete Fourier transform. So here in this session we had seen multiplication of two DFTs or circular convolution property of discrete Fourier transform, okay, where we can perform the circular convolution of these two sequences. So the circular convolution of the two sequences in frequency domain is nothing but the multiplication of their respective DFTs, right? So as well as we have seen how to determine the circular convolution by using its formula and by using graphical method here, right? In next session we'll be performing or we'll be determining the circular convolution by using the discrete Fourier transform or the circular convolution or multiplication of two DFTs property, okay, will be determining the circular convolution. Thank you for joining this session.